So what's an imaginary number? An imaginary number has to do with the square root of a negative number. When we write imaginary numbers, we usually use the letter I to indicate the square root of -1. So if I is the square root of -1, what do you suppose I squared is? Well, I squared would be the square root of -1 times the square root of -1. So I squared equals -1. These are the two most common powers of I that you're going to see, but we could still go further. I cubed. I cubed would be I squared times I, which would be -1 times I, or -1I. Okay, I to the fourth. I to the fourth would be I squared times I squared, which is -1 times -1, which is 1. You could continue this pattern on and on and on, but you're going to see a little pattern emerge. We had I, -1, -I, and I. So as we continue up, we're going to follow that same pattern. Now, I to the fourth is the one I really want to focus on because I to the fourth is 1. We can simplify powers of I by dividing out I to the fourths in those expressions. So let's say we had I to the, let's start low, the 10th. We could write this as I to the fourth times I to the fourth times I squared. Well, we remember that I to the fourth and I to the fourth, those are both 1. So I to the 10th is the same as I squared. If you remember that from our original pattern, I squared is -1. So I to the 10th equals -1. The shortcut for doing this is you're basically just dividing 10 by 4. And you end up with a remainder 2 and a remainder of 2. So I squared comes from that remainder. So let's look at another power of I. Let's say we had I to the 15th. See, we're starting low. Again, let's divide by 4. 15 divided by 4 leaves me 3 with a remainder of 3. So I to the 15th is the same as saying I cubed. If we remember from our original pattern said that I cubed was -I. Okay, how about I to the 106th? Okay, we have 106. Let's try to get out all the 4s, all the I to the fourths. So we need to take 106 and divide it by 4. So that's going to give me 2. 26 is 6, remainder 2. So we're going to be looking at that remainder 2. We're going to find I squared, which is -1. Now, for the most part, we're going to be looking at I and I squared, but I just wanted you to be prepared for simplifying higher powers of R just in case your multiplication problems get a little bit bigger and you end up with more I's. I equals the square root of -1. And we use this property to help us simplify some of our solutions to quadratic equations. Often these solutions are in square roots. So we can simplify square roots like we did with numbers, but now we're going to add in this I part to it. So let's say we wanted to find the square root of -81. Well, let's split it apart first, like we did when we simplified square roots. You might want to go back to that video if you haven't done so yet. So, square root of 81 is the square root of -1 times 81. Well, we can split our square root apart, so we'd say this is the square root of -1 times the square root of 81. The square root of -1 is I, and the square root of 81 is 9. So our solution to the square root of -81 is 9I. Let's look at another one while we're thinking about these simplifying square roots. Let's say we had the square root of -28. first, let's start out by splitting it into the negative and the positive number. So negative 1 times 28. Now let's think about that 28. Are there any perfect squares that go into 28? Well, 4 goes into 28. So this could be in the square root of negative 1 times 4 times 7. So I have a couple of perfect squares that can escape from the square root. The square root of 4 is 2, so that comes out. The square root of negative 1 is I, so that comes out. And we're left over with the square root of 7, which is irrational, so that's our final simplification of the square root of negative 28. When we experience imaginary numbers, we're probably going to see them in a little bit more complicated situations than just things like the square root of negative 81. So we're going to look at another couple of examples where we have some fractions and some other simplification involved, and then that'll be it for imaginary numbers. So let's say we had 5 plus the square root of negative 16. Now let's focus on the square root of negative 16. This can be written as the square root of negative 1 times 16. Well, I know the square root of negative 1, that's I, and I know the square root of 16, that's 4. So this is really 4i. I'm going to bring down that 5. So my problem becomes 5 plus 4i. And think about combining like terms. We couldn't combine things that weren't the same. Well, here we have a real number, the 5, and an imaginary number, 4i. We can't put those together. One's real and one's imaginary. So we have to leave our answer like this in complex number form. Okay, let's try something a little bit more different. Let's do 6 minus the square root of negative 32 divided by 2. Before we worry about the big fraction and all the other numbers, let's focus on our negative square root. Square root of negative 32 can be rewritten. It can be written as the square root of negative 1 times 32. Now we want to think about that 32. Are there any perfect squares that go into 32? 4 goes into 32. Are there any bigger perfect squares that go into 32? This one is always a tricky one, and it's one to remember because you'll see it a lot. 32 is actually divisible by 16. So we can rewrite this as the square root of negative 1 times 16 times 2. Now, negative 1 escapes and becomes an I. 16 escapes and becomes a 4. And the square root of 2 has to stay like he is. Now let's go back to the original problem. I know you forgot about it, didn't you? This is 6 minus 4i times the square root of 2, all divided by 2. We can simplify this a little bit further because 6 is divisible by 2, and so is 4. 6 divided by 2 is 3, so the real part of this number is 3. 4, or negative 4 divided by 2 is negative 2, so the imaginary part is minus 2i times the square root of 2. Now we've finished simplifying our complex number. This was mainly looking at imaginary numbers only, so we were looking at I, but we also added in these complex examples at the end. There's going to be another couple of videos focusing more on complex numbers and the relationship of the real part and the imaginary part.